In today's lesson, you will be able to use your angle pair relationships to prove that two or more lines are parallel. This is our unit number 2, lesson number 3 on verifying that we have parallel lines. Now that we know that parallel lines have special relationships, we can use them to prove that we have two lines that are parallel. We are going to use a method called the two and true method. Okay, that two and true method means that we need angles for two different intersections. Okay, so that means I have one on each line. Okay, and what I mean by that is if we have these two hopefully parallel lines and I label these, okay, I am going to have one of my angles be on the top and one be on the bottom. So I have to have a 1, 2, 3, or a 4 with a 5, 6, 7, or an 8. And a true statement about their relationship. So the true statement about their relationship has to do with all of our angle relationships we've learned. You have to have congruence or equal to 180. Okay, so they have to be congruent or equal to 180 depending on what kind of angle they have. So we have alternate interior, alternate exterior, consecutive interior, consecutive exterior, as well as corresponding that we're going to be able to use to prove congruence. Okay. So in the examples on your notes, the first example says, given that we actually know that AD is parallel to EH, okay, we want to solve for X and all the missing pieces. So we are going to continue labeling our A's and our B's like we've been doing all along. So I'm going to have A, B, B, A, B, A, A, B. Okay, you're going to plug in A, B, A, B, B, A, B, A. Okay. We're going to look and ask ourselves, do we have two A's, two B's, or an A and a B? In this case, I have two A's, which means that these are congruent. A's are equal to A's. These are actually alternate exterior angles, so I'm going to write that in here so that we remember. Okay, and they are equal to each other. So my equation would be 3x plus 72 is equal to 6x. And I'm going to solve this. So I'm going to get rid of my 3x on this side. End up with 72 is equal to 3x. If I divide by 3 on both sides, I get 24 is my x. Okay, and then it wants me to solve for all my missing angles. So what I'm going to do is I'm going to come over here and I'm going to plug in 6 times 24. And I'm going to get 144 for those angle measures. So all of my A's have to be 144 degrees. Okay? All of my B's, an A and a B add up to 180, so I'm going to do 180 minus 144. This gets me 36 degrees. So all of my B's are 36. That's all we're doing for that one. So we already knew that they were parallel. Number 2 is worded a little bit different. We want to know if these lines were going to be parallel, what would my angle or the value of my x have to be? So here, I want these two lines to be parallel, and there's only one value of x that will make that true. Okay, so we have AB, BA, AB, BA. So what I'm going to do is I am going to look at my 4x and my 6x. They have an A and a B. I know that A's plus B's are equal to 180. So I'm going to plug in 4x plus 6x equals 180. When I add my x's together, I have 10x and it's equal to 180. And then to get x all alone, we have to divide by 10. So x will be 18 if I want those lines to be parallel. This next one is a little intimidating, but I promise it's going to be pretty easy if we follow our two and true method. So two and true, okay? So it says determine if the following statements prove that A is parallel to B. So all along we are trying to prove that line A and line B are parallel. It's not something that we can assume when we're trying to verify they're parallel. They don't tell me they're parallel. So what I'm going to do is I'm going to look and see what they give me. Okay, so here they've told me that angle 1 is congruent to angle 8. So I'm going to label my A's and my B's. angles has to touch line A and one has to touch line B. And this is going to be true for every problem we do. Okay, so I have one angle touching, angle 1 is touching line A, angle 8 is touching line B, so that is accurate. This is good. And is it true that they would be congruent with the relationship they have if they were parallel? And it is, because I have A is equal to A. Okay, so A equals A. So this is a yes. And it's a yes because they are alternate exterior angles. Okay, they are alternate exterior angles. Alternate exterior angles are congruent when I have parallel lines. Okay? So we are going to continue this and go on to the next one. So I'm following the same pattern. For this one, I am doing 4 is congruent to 5. So I have angle 4 is congruent to angle 5. So I have 1 that sits on angle A. So angle 4 is on line A. I'm sorry, I misspoke. And angle 5 is sitting on on line B. Okay. If the lines were parallel, they should be congruent because I have an A equals an A. They are congruent according to letter B, where it says angle 4 and angle 5 are congruent. So this is going to be a yes, because they are alternate interior angles. Okay, we have them on the inside of those lines, and they are on opposite sides. Next we have angle 6 and angle 7. And while they are beautiful and diagonal from each other, they are what we call vertical angles because they're across from each other, and they are equal. B is equal to B, and this tells me that I have 2 equal angles, 2 congruent angles. One of them is not sitting on line A. Both of these are touching line B. Okay, we are not going to be able to use this because I do not have 2 angles, one on each of my lines. So this is a no, and I'm going to say that vertical angles cannot prove that we have parallel lines. Okay? It cannot prove it. Letter D has 3 and 7. So now we have 3 and 7. Okay? 3 and 7, one is on line A, one is on line B. They are both B's. B's are equal to B's. So I'm going to say yes, okay? And these are congruent because they're on the same side of my transversal, in one's inside, one's outside, so they are corresponding. Letter E tells us that angle 1 and angle 7 are going to be 180 degrees. So angle 1 and angle 7 are currently 180 degrees. So I'm going to go ahead. I have angle 1 and angle 7. If I have my A's and my B's that I just erased, you have an A and a B, and we know that A's plus B's are equal to 180, okay? They are equal to 180. You have one sitting on line A and one sitting on line B, so this is going to be yes. We can use it to prove that they are congruent. And they are on the same side of my transversal, on opposite, or they're both in the corners. They're both outside, so they are consecutive exterior. Okay. Next, I have angle 5 and angle 6. So angle 5 and angle 6 are right here. This says that they add up to 180. Okay, I have an A and a B, A's and B's add up to 180, so that would be true. But I do not have one angle that is touching A and one that is touching B. So this is a no, okay, and it's a no because it's a linear pair, and linear pairs cannot prove that we have parallel lines. Okay. And then last but not least, we have 3 and we have 6. So we have 3 and 6. Okay. Okay, they are on each of my parallel lines or hopeful parallel lines. Okay, I have 2 B's, so they should be equal. B is tells me they add up to 180. If they are not equal, we cannot use them to prove that they are parallel. So, because they are not 180 when I have parallel lines. No, and because they are alternate interior angles, should be congruent. They should not be 180. Okay? In example 4, we're going to ask ourselves if we have parallel lines or not. So I have M and N. I have 1 on each of my lines. That's a good start. I'm going to label my A's and my B's. Okay? I have an A and a B. They should add up to 180. So I'm going to do 143 plus 37. That gives me 180 degrees. So that works. So these are parallel. I can use it to prove parallel lines because I have consecutive interior angles. If you need to review your vocabulary, go back to our original videos on this and all of your original notes. All of the diagrams are in your notes. Consecutive interior angles. Number 5, I have these 2 right angles, okay? They have my right angle symbol in there. They're both 90 degrees, okay? I do not have one that touches M and N. They are both on N. Okay, so automatically I can say no. So while they are both 90 degrees and equal, we cannot use them to prove that we have parallel lines. And the reasoning is that vertical angles cannot prove congruence. Or not congruence. Cannot prove that we have parallel lines. Okay. Number 6, we have 106 and 13. And I'm going to label my A's and my B's. Okay. So I've got these 2 angles. I have one that is touching line M and one that's touching N. That's a good start. So that's my 2. And I need to know if they are true. So I have a B and a B. They should be equal. Okay, if I have parallel lines, so I have 106 and 113. 106 and 113 are not congruent. Okay? So this is a no, okay, because I have alternate exterior angles. And they must be congruent for parallel lines. Okay. Number 7, we have a 114 and a 114. Okay, they're both in opposite corners. So I have A, B, A, B, A. I have an A and an A. A is equal to A. Okay, they are equal. There is 1 on each of my lines. 114 equals 114. They are alternate exterior angles. Okay, they must be congruent in order to be parallel, so this is a yes, because they are congruent. Okay. Number 8, we've got this beautiful diagram. I have one that's touching on line M and one that's touching on line N. Okay, I have my A, my B, my A, my B. I'm just going to keep labeling. Okay. Inside of here, I've got my A's and my B's. Okay, so I have an A and a B. They have to add up to 180 degrees in order to prove that I have parallel lines. So I have 130 plus 50. They are equal to 180. So check. Okay, so this is a yes, and they're on the same side of my transversal and the inside, so they are consecutive interior angles. Okay, and last but not least, we have number 9. We've got this beautiful diagram. I've got one touching each of my lines. I have an A, a B, an A, an A. They should add up to 180. Okay, but 120 plus 70 equals 190. This is going to be a no because there is no angle relationship.